Hello everyone. In this video, we present our project titled Virtual Machine for Multi-User Security Practice, which is part of the video project-based learning assignment for operating system week 14 and 15. This project is completed by me, Robi Yudhistira, Muhammad Zosa Romero, Muhammad Rehan Zaki, and Edward Wu. The main objective of this project is to simulate a multi-user operating system environment using virtual machine. We aim to implement security mechanism based on user groups and permissions, and to practice access control using the Linux operating system. In this project, we use Ubuntu desktop installed on a virtual machine. The system is configured with multiple user roles such as an administrator, staff, and guest, where each role has a different access permissions. These scenarios demonstrate the application of the principle of least privilege in operating system security. And next, we're gonna go to conceptual explanation.
Good evening. My name is Muhammad Ranzaki, and now I will explain to you about virtual machines, an overview of virtual machine, user group, and permission. So, the first is what is virtual machine exactly? In this project, we use virtual machine. A virtual machine is software-based computer that runs inside a physical computer. It allows us to install and operate an operating system such as Ubuntu, Linux, without affecting the host system. Virtual machines are widely used for testing, learning, and security experiments because they are isolated, safe, and easy to reset. And then we got multi-user operating system. A multi-user operating system is an operating system that allows multiple users to use the same system resource at the same time with different access rights. Linux as a multi-user operating system by design, which makes it suitable for simulating real server and enterprise environment. And next is user and group in Linux. In Linux, users represent individual identities that can log into the system. Each user can belong to one or more groups, which are used to manage permission more efficiently instead of assigning permission to users one by one. Administrator can assign permission to groups. And what is file and directory permission? We got read, allow viewing file contents, and then write to allow modifying files, and then execute allow running file or accessing directories. These permissions are applied to three levels: the owner, group, and others. And then we got principle, the least privilege principle. The most important security concept we apply in this project is the principle of least privilege. This principle means that each user is only given the minimum level of access necessary to perform their tasks. For example, staff user can access shared work folders, while the guest is user are restricted and cannot access sensitive resource. And then why VMs for security practice? Virtual machines are ideal for security practice because they provide isolation between the system, support safe experimentation, and closely resemble real-world server and cloud environment. Any misconfiguration or error inside the VM does not affect the host and the system. Therefore, using a VM helps us understand how operating system security work in a controlled and realistic environment. Thank you.
Hello again. In this stage, we're gonna start by creating a new virtual machine with click machine here and click new, and we're gonna give the name is Ubuntu, and we set the type to Linux, and we set the version to Ubuntu 64-bit, and we're just gonna click next. So I'm gonna allocate the RAM to 4 gigabytes or 4069 megabyte. So if the device is limited, it can be set around 2 gigabytes or 2048 megabytes. So uh, which is this is sufficient for running Ubuntu desktop smoothly and while still maintaining the system stability. So we're gonna just go next, and for storage configuration, we create a new virtual hard disk using VGI format with dynamically allocate, and mm, I'm gonna set the disk size around 25 gigabytes, which is enough for operating system and security practice files. Just create, and voila, And now we're gonna configure the network. So the network, okay, so the network conf mode is configured using NAT. This configuration allows the virtual machine to access internet while keeping it isolated from the host network, which is more secure for security practice. And finally, we're gonna mount the Ubuntu desktop ISO file. Go to storage, click the empty here. Okay, now we're gonna click the icon CD here. So make sure we already download the Ubuntu ISO file, because I'm already download. Choose. Oh, sorry. Okay, because I'm already download it, so I'm just gonna click here, and this ISO will be used to boot the virtual machine and install the Ubuntu operating system in the next stage. Click OK, and voila! At this point, the virtual machine configuration is complete. In the next section, we will proceed with the Ubuntu operating system installation.
And I'm from international class 48, major in informatics from Telkom University. Now I will explain about how to install Ubuntu in virtual machine on Windows 11 step by step. The first step is we need to install Ubuntu ISO file from uh, Ubuntu website. This is the official Ubuntu of website. Okay, we need to install this from this one, and I will install Ubuntu 24.04.3 LTS. Alright, after we install this file, we need to go through Open VM Manager, VirtualBox Manager. Then we click New here, and I will name it Ubuntu. And the next step is find the file ISO here. This is file ISO. Alright, after this, we need to set up attended guest operating system installation. Now, I want to rename it my name, Romero. Oh yeah, from here, we cannot be write capital words like this. Yeah, we need to low words, and then I want to okay, my password is the same like username. The Ubuntu here. My hostname is Ubuntu, and then domain name I want to install in background and install guest edition, and then this one. The green color is the recommendation for the system because we cannot be maximize this one, and this is the optimal size here. But I want to just the half green. Alright. Okay, this is set default. It's okay, it's fine. But I need to create a new filter hard disk. This one is the location directory here. The location directory is already default from the system. And then we just need click finish. Okay, now the Oracle VirtualBox Manager processing the Ubuntu. We can click show for open the Ubuntu window. the system is configuring the system. Okay, the installation is already completed, and then we just need to have fun with this Ubuntu. So we need to check the terminal. We open the terminal to check we can update. I want to update. So, okay, now I want to set the time. We just need to search from the time. Click the end time. Or select the time zone. I want to Indonesia. Jakarta. Okay, this is already set the time. The actual time is 22 o'clock, and here we exit, and then we back to the terminal. And yep, we already installed the Ubuntu in virtual machine on Windows 11. And then check the who am I? Yeah, Ubuntu is already done. And thank you for this session. Thank you for this session. Thank you very much.
Hello, I'm here to cover section 6, 7, and 8. And then, yeah, let's just start on with it with section 6, which is user identification and role. It's kind of the same thing, actually. Why am I even saying it like that? Okay, now let's start with our first user, which will be, see, why not, admin Raihan. We'll have Raihan as the admin, and yeah, the password, just input all that other stuff. This isn't as important. Oops, another access rate. So now let's add the second user, also, using the sudo add user. Forgot to mention that, I guess. Which will have a staff and Robbie as the staff. User, and then as the final one, as the guest for this explanation would be Sosa. Wait. But I remember, I'll just wait. There we go. I already created another user, so I had to do that. Hi. So now we're going to be assigning admin privileges to Raihan since he's the admin this time around. So let's we use sudo user mod dot dash a capital G and then sudo admin Raihan. Boom. Now let us test if these accounts were made properly, which logging in on each of them using the su dash command. Let's see, Raihan, password, there you go. You can even see it there, but let's just use the who am I just to be sure. Boom, admin Raihan. Now let's do it for the others. Su, staff, Robbie. Yes, I think, yeah. And then just do the basic stuff, that stuff, Robbie. And then now the final one for Zosa. Guess one, Zosa. Password, who am I? And boom. So with this, basically each user has their own account, so all their actions are trackable, ensuring accountability and makes security audits easier. That's the explanation for section 6. Now let's move on to section 7, where we are going to be making the shared folders and the groups. Let's start with the group, which is sudo group add. Let's see, what should I name this thing? I don't know why it takes so long. Project 07. No, I'll just name it group. I think we're fine with generic. God, I hope we are. And boom. There we have the group. Now let's add the intended users for this group with the sudo usermod -ag. First, we'll have to got the group name first, and then input the user. We'll have Raihan, and then just copy it again. Group 07 and stuff. See, we're not going to be inputting Zosa here because he's acting as the guest. Yeah. So now let's just make the make the shared folder with the sudo mkdir command. Let's see, what should I name it? Shared 07. Why not? And then now we're going to be using this to connect the group with the shared folder. 07, shared 07. Boom. And then now we're going to be giving privileges to the authority. I'm not sure. Yeah, privileges, I guess. Let's just stick with that. To the groups, depending on their roles, Then now test, just to see if they're actually connected, we'll use lsld with the shared in the last one. Boom. As you can see here, group 7 and is connected to the shared folder. With that, with this, guests will have no access since they're not in the group, and then staff will have access to the thing, albeit right now only opening. We'll soon see with the section 8, and admins will have free reign with it to create and to delete and such. So yeah, that marks the end of section 7. Now let's move on to section 8. We're going to be starting the examples from putting in this, yeah, the admin, which is Rayhan. So let's see, user, yep. And then now let's see how they're going to be able to access each of the files. Shell 07. Let's see, since the admin is in the group, he can open it, of course. Now let's do a test to basically make a temporary txt, we'll say, like temp txt. Boom. And then let's just check ls and see it's clearly right there, created. And so with this, it shows that the admin is able to go inside the folder and also create temporary files and permanent ones. Sorry. So now let's move on to the second one, would be the staff. Staff, Robbie. And we'll see how the staff is compared with the admin's privileges. Now let's try to open the folder, which he can because he is a part of the group. But when we do try to do the same thing with the admin with the txt, it'll have permission denied because he is only a staff. He can only do so much. He's not an admin. So let's exit and now move on to the final one, which is Zosa's guest user. Guest one, Zosa. There you go. Compared to the others, since he's not in the group, it's going to be pretty obvious what will happen here. So when we do this, wait, just like that, boom, permission denied because he is not in the group, unlike the others. That basically marks the end of section 8 and my part, I guess. Thank you for listening and goodbye.
All right, so I will continue to the section 9 to the security analysis. But the first thing is we have accountability. So we can just as Edward type who am I and groups. So this command show the current user identity. As we can see here, who am I admin Raihan, staff Robi, and then quiz Dosa, and group membership. User identification is important for accountability and security auditing in a multi-user operating system. So now we're gonna look at the security analysis. Uh, while the SU admin Rahan, then CD shared 7, he can access the file, right? And he can change the and make a temporary file txt. So, and then the SU staff Robi, he can touch, he can open the file, but he cannot touch the temporary file that admin Raihan create because uh, different authorities. So this confirms that authorized user can access and modify shared resource according to their assigned permission. And the next is the security analysis. Oh, my bad. Security, I mean, yeah. The GUES Zosa, he cannot touch the shared file. This will show the permission denied. This demonstrates that unauthorized user cannot access protect system resource. The Linux permission system successfully prevent illegal access. And then this is the whole system limitation, right? Standard Linux permission are limited to owner, group, and others. As the number of user increases, permission management becomes more complex. The system also focus on local access control and does not include network security or intrusion detection. And this is the analyze risk of wrong permission. This is I tried this in my laptop, not in at work Ubuntu, but it's just the same. So the lsld shared command is this directory were configured with right permission for all user. Guest user could modify or delete sensitive data. Incorrect permission configuration increase the risk of data loss and system compromise. And the last is the security enhancement. So in my Ubuntu, I try to type sudo -l. This is the admin command, optional, but you can try. The security can be improved by implementing access control lists for final permission control, customize sudo policies for administrative access, and audit log to monitor user activity. These features are widely used in real world Linux server and cloud system. That's all for me. Thank you.
To conclude, this project demonstrates how a Linux-based virtual machine can be used to simulate a multi-user operating system environment. By configuring users, groups, and file permissions, we implement access control mechanisms to manage how system resources are accessed. Through this process, we applied the principle of least privilege where each user is granted only the permissions required for their specific role. For the real-world relevance, these concepts are highly relevant in real-world server and cloud environments, where multiple users access the same system without different responsibilities. Incorrect permissions configuration can lead to unauthorized access and security vulnerabilities. Therefore, understanding operating system level security is essential for building and maintaining secure system. From a group perspective, this project emphasized the importance of clear task division and collaboration. Each member contributes to different parts of the system, which reflects how real IT and security teams collaborate when working on complex technical projects. Thank you for watching our project presentation.